You jog 3 kilometers at 50 degrees east of north, 3 kilometers at 15 degrees south of east, and an unknown distance and direction. Oh, okay. If you end up at 5 kilometers east, determine the magnitude of the unknown vector that you traveled. Okay, so let's draw this. 2 kilometers east of north. East of north, let's just make sure where I'm going to be. East of north is going to be over here. And then south of east. South of east will be down here and then end up over here. So I can draw it like this. Just to make sure I know which quadrant I'm going to be in. So this will be my x and y, positive x, positive y. And I travel 3 kilometers at 50 degrees east of north. Which way is north? North is this way, east of north is this way, and we're going 50 degrees. So just more than 45, so about that. Okay, so there's V1. This angle here is 50 degrees, and this is V1 vector. Then 3 kilometers at 15 degrees south of east. Which way is east? East is this way, like this. And south of east is down, so we're going to be like that. And 3 kilometers, so about that far. Okay, and that angle there is 15 degrees. This guy is called V2 vector. And an unknown distance. So we did something. If you end up at 5 kilometers east, so I usually say my resultant, I usually draw in red. If you end up at 5 kilometers east, so east is this way, so 5 kilometers is like this. There. Okay, we'll call that V final vector. It asks, determine the magnitude of the unknown. So we have this unknown vector here. We don't know what this is, and we're trying to find this guy, V3 vector. Okay, well, first things first, let's do the components. Okay, so I have 2 components here. I have this V1 vector. Let's do that first, because I know I need to do it anyways. So 50 degrees, and this distance was 3. I'll call this x, and I'll call this y. So x is equal to 3 times x is going to be the sine, because it's opposite, so it's going to be sine of 50. And y will equal 3 cosine, because it's adjacent. Cosine of 50, okay? And then my other angle is this one, this crazy one down here, like that. And this one is going to be 15 degrees. And the distance is 3. And again, I'm going to call this x, and I'll call this y. So x is going to be equal to 3. This times x is the cosine, because it's adjacent. So cosine of 15. And y will equal 3 sine of 15. Some people like to associate x with cosine and y with sine, but you can see here that it depends on where the angle is referenced to. If it's referenced from the y, then it's actually opposite. X is with sine and y is with cosine. And if it's referenced from the x-axis, then it's like that. So it's not a good idea to memorize that. I always had memorize that sine is opposite and cosine is the adjacent. Okay, so here we go. So we had 50 degrees here, so sine 3 sine 50 is going to be 2.298, and then we want cosine is going to be 1.928, and then we have 3 cosine of 15 is going to be 2.8978. Let's try that. And then 3 sine 15 is 0.776. Okay. So let's try to write this down here. So what we know here is we know that v1 vector plus v2 vector plus our v3 vector is equal to v final vector. That's true, right? So if I 1, this vector plus this vector plus this vector equals our resultant vector, right? You get to the same point. That's the final point right there. X marks the spot. Right there. That's our final point. And we're saying that 1, 2, 3 right here is equal to just going there directly. Okay, but we're not trying to find v final anymore. We're trying to find v3. So we have to subtract this. We have to actually subtract v1, v2 vector from this side and subtract v1 vector from this side. So we have to do the same thing over here, subtract v1 vector and subtract v2 vector, and now we can solve for v3 vector. So this works the same way as with regular mathematics. It's just that we have to have vectors. And I'll show you how to do that when we actually have vector format. It's the exact same thing though. So there's the equation that we're actually trying to solve right there, right? We're trying to solve for v3 vector, which is equal to v final vector minus v1 vector minus v2 vector. Okay, let's write that down. So it's going to be v final vector minus v1 vector minus v2 vector. How you apply the minus is if you add all those together, right? This plus negative v1 vector plus negative v2 vector is going to be equal to v3 vector. Okay? Now, to apply a minus vector, all you really do is you take all the components of that and you make it negative. Right? So if I was traveling this way, to make it negative, it would just be this way. So I take my x component, I make it negative, and I take my y component, I make it negative. That's all you do. You take all the components and make it negative. So let's do the final one first. Final one, it said it was just at 5 east. So it's going to be 5x hat plus 0y hat. Let's do this one, v1 vector. Well, v1 vector was positive x and positive y. Positive 2.2898 and positive 1.928. But this, because I'm making it negative, I'm actually going to apply the negative right now. So it's going to be minus 2.298 x hat minus 1.928 y hat. So when I add, now I have to add them because I've already applied the negative. Minus v1, because v1 vector, if I took this minus away, would be positive this value plus this value. But now that I made it minus, I made minus, so I make minus here and a minus there. So it's just minus that vector. And this is the way I like to apply it because now when I add it, it's just dead simple. I don't have to worry about this negative thing all traveling around all around. So let's do the same thing with v2 vector. v2 vector is a positive x and a minus y. So it's going to be positive y and minus x. So it's going to be minus 2.898 x hat. And this should be minus, which means plus now, 0.776y. So it's a little confusing knowing. That's why you should do all the other problems first to really understand this. But it's a little confusing. Apply these negative vectors. But after you get the hang of positive vectors, these negative vectors are literally just the negative of that vector. And that's exactly what a negative number is, right? A negative number is just the negative of the positive number. And the thing that this applies to a vector, it just applies to all the different components. So now we just add all these numbers together. So it's going to be 5 minus 298 minus 2.898 equals negative 0.196 x hat. Well, that makes sense because it looks like I do have to go backwards here. And it should also be minus y here too. Let's figure it out. So negative 1.928 plus 0.776. And that's going to leave me with minus 1.152 y hat. Okay, so there's the direction of that v3 vector. It was minus x hat and minus y hat, and that makes sense. It looks right compared to my picture. Now, your picture might always be off just slightly, but in this sense, it does look pretty close. And that's just for the magnitude here, so we're just going to look for the magnitude. So we're going to square all our components, v3x squared plus v3y squared. Okay, and remember, you don't put these negatives apply inside the squared, so they don't even really get applied at all. So don't put the minus outside here. It's plus minus 1.152 squared. Okay, so v3 vector magnitude is going to be equal to that number squared, which is going to be a positive, and plus, what was that one? That one was this one. So this one plus 0.196. 196 squared equals square root answer equals 1.17 kilometers. That was the unknown distance.